Hey everyone, let's go ahead and talk about this week. Um, just like usual, there's not a formal Zoom meeting, but if anyone needs me to Zoom, just make sure you let me know and we will make that happen. Otherwise, make sure you go to the Google form in our Google Classroom and you're filling it out to let me know you're checking in on things. Ask me questions there, email me questions if you need to. Monday, you're going to have an ed puzzle assignment that has to do with physical and chemical properties. That's the next thing we're going to learn about in our chemistry unit. After that, on Tuesday, make sure you do the ed puzzle about physical and chemical changes. Both of those, make sure you take your time, answer slowly, be careful, because as you know, once you lock in an answer on ed puzzle, they are locked in. So, and you can't go back and change them. So make sure you take your time and be careful with those. And then on Wednesday through the rest of the week, your assignment is a physical and chemical changes activity where you find some of the physical and chemical changes that happen in your everyday life. You're going to go to a couple of websites and pick through the list of examples that they give. There's some physical change examples, some chemical change examples, and you're going to read through those, pick some that you find interesting, or just at least pick some. You're going to pick five each, and then you're going to describe why they are a physical change or why they are a chemical change. And you just do it right in the Google Doc there. Um, Other than that, that's your assignments for the week. So now let's shift gears a little bit, and I want to talk about properties of matter and changes of matter. So physical properties, chemical properties, physical changes, chemical changes. And let's take a second here and look at those. All right. First, let's look at kind of the nature of matter. So we already know a little bit about matter and how matter is anything that takes up space and has mass. So I am matter, you are matter, your chair, your table, the air around us, like everything that has a mass and takes up space is matter. Um, for some examples, again, it's anything that you can observe with your senses. And even though sometimes you can't, like air, you don't see it, but you can feel it, you can smell it. So if you can observe it with your senses, it has matter. You can observe rocks, trees, a bicycle, the air, everything that exists that takes up space and has mass is matter. Now, something that we don't count as matter is energy. So sunlight, heat, electricity, it doesn't have a mass, it doesn't have volume. Those things are not matter, but anything that has mass and takes up space is matter. And that's what we're going to focus on here. First, let's look at the physical properties of matter. A physical property is a property that can be easily observed without changing the identity of the substance. What that means is if you were to look at something and what you can observe about it, that is its physical property. And if it's something that you can change and it does not change the identity of the object, it is a physical property. Some examples would be viscosity, conductivity, malleability, hardness, magnetism, melting point, boiling point, density, color. All of these things you can observe, and if you were to change them, it would not change the identity of the substance. Like if you were to look at the atoms and molecules or compounds or whatever under a microscope, they would be exactly the same. If you were to mess with them and change them, they would not change. So physical properties are observed, and you can't change the identity of the substance by changing them. Now, some examples, solubility, the ability of something to dissolve like sugar in water, that is a physical property. When something dissolves, it doesn't change the substance, it just mixes. Conductivity, a material's ability to allow heat or electricity to flow through it, that is a physical property. Like metal is very conductive. It has high conductivity. Wood, not very conductive. It has poor conductivity. But conductivity is a physical property. Malleability, this is a substance's ability to be like hammered thin or molded differently. So how it molds or hammers thin is a physical property. Melting and freezing point, these are the temperatures where solids become liquids or liquids become solids. These, same with boiling point, all of these are physical properties, because if something melts or freezes or evaporates into a gas, it does not change the identity of the substance. So that would be considered a physical change because of these are physical properties. Think about ice. Liquid ice is water. Solid ice is ice. Gas water is, condensation or gas of water. If you look at all three of those, solid, liquid, or gas, if you look at them under a microscope, the elements, the compounds are exactly the same, no matter if it's a solid, liquid, or gas. So the identity did not change, meaning those are physical properties, or if they change, those are physical changes, not chemical. We also have density. This is how close together the particles of something are. Things with low densities float, things with high densities sink. Now, when we think about physical changes, those were all properties. Now, physical changes, again, you change the appearance without changing the identity. If you got a haircut, your hair is shorter, but it's still hair. If you mow the grass is shorter, but it's still grass. If you chop some wood, the shape changes, but it is still wood. These things can be reversible or irreversible, but all they do is change how it looks. If you were to look at the atoms, those atoms are exactly the same. Changes shape or size, it dissolves, it changes the state of matter, solid, liquid, gas. All of these things do not change the identity. So those are physical changes. Now, again, they don't change the identity. Things like cutting, crushing, reshaping, changing state of matter, dissolving. Here's a picture of sugar dissolving inside of water. All of those are physical changes. They do not chemically change. Their identities do not change. So those are physical changes. Now let's shift gears and look at chemical properties and chemical changes. A chemical property is an ability to produce a change in the identity of the matter. So in this case, you do change the identity. Some examples would be flammability, reactivity. So flammability is an object's ability to burn in the presence of oxygen. If it can burn, and it does burn, that is a chemical property and a chemical change. So reactivity, this is how readily a substance combines chemically with other substances. When things have a chemical reaction and combine chemically with other stuff, or the compounds separate because of chemical reactions, those are chemical properties and chemical changes. Because again, the atoms change, it does change the identity of the substance. If something is corrosive, like if a metal is eaten away at by acid or becomes rusty, like all of those are chemical properties that lead to chemical changes because it does chemically alter the identity of the substance. Chemical changes occur when a substance reacts and forms one or more new substances. You know there was a chemical change if you see a color change, if you see a gas produced or, the liquid's bubbling, if you see a precipitate form, that's a fancy way of saying a solid forms inside of a liquid. If things absorb or release energy, like gets hot, gets cold, light's given off, all of those are indicators that a chemical change has occurred. Now, some examples of chemical changes, burning or combusting, if things are on fire, if you cook things, you know that a chemical change happened. Because again, think about it, these are irreversible changes. Once you cook a piece of chicken, you can't uncook it into raw chicken. That is a chemical change. When things burn, there's a color change, odor change, gases are produced, they get hot. Corroding, like these metal pipes here, there's a color change.
You can physically see that they look different. You can't uncorrode it. Same with rusting. It's kind of the same thing. Look at these rusty nails. Once metal has rusted, those atoms are not going to turn back. Molding, you can tell that mold has occurred. There's a color change. This is a unique case, though. Decaying, look at this old rotten apple. Once something has decayed, there's a color change, but it is not reversible. It is not going to go back. Digesting, once you insert food and drink in your body, there's a color change, odor change, a gas is reduced, energy is released. You can't undigest things that you've eaten or drink. So these are all chemical changes. They're irreversible. Same here. If you look at plants in the fall, like when the leaves start turning from green to red or orange or yellow, chemical reactions inside those leaves produce pigments that change the colors. So a chemical reaction occurred. Effervescent tablets, these are added to water. The citric acid breaks it down. They produce carbon dioxide bubbles. Seeing those bubbles form, like you can tell a chemical reaction occurred. The Statue of Liberty, it used to be shiny and orange and had that copper-like color that you can think of when you think of copper. But over the years, it's reacted with water, carbon dioxide, and it's formed like a green copper compound on the outside. Like these are all irreversible chemical changes. That's another big hint. If it's irreversible, you know it was a chemical change. Now, finally, let's look at mixtures and compounds. Mixtures are things that you can physically separate. Like if you look at this picture here, these different colored jelly beans, they might all be in the same bowl, but they're not chemically combined. They're mixed together, but they're not chemically together. You can still separate the parts. Compounds, you can break them down through chemical changes, but overall, once they are together, chemically combined. If something like sodium and chlorine combine and form a salt, that is now a compound, not a mixture. Those are not easily separated without chemical changes. So that's the big difference there between a mixture and a compound. Mixtures can be physically separated. Compounds are chemically combined. So the only way to separate them is chemically. And that's the difference there. Okay, that's the information about chemical and physical properties and chemical and physical changes. If you need to re-watch the video, make sure you do. You'll need this information for the assignments. And if you have any questions, as always, make sure you send me an email.